November 1969, during their climb back to the command module, Commander Charles Conrad and lunar module pilot Alan Bean released the Apollo 12 launch vehicle and crashed it into the moon. After the impact, something unexpected happened. The moon is said to have rang seismically like a bell for more than an hour. Walter Cunningham makes a statement about what happened, saying that with Apollo 12, people refer to it as an accident, but it was not a crash or an accident. It was actually a directed deorbit of the rocket used to lift off the lunar module, and the crew stopped the launch vehicle and crashed it into the ground, right near where they had a seismograph installed. It then vibrated, providing an early clue to how solid the moon's surface was. The surprising thing is that, suddenly, the moon began to ring like a bell and did so for almost an hour. At that time, NASA Chief Wernher von Braun decided that for Apollo 13 they were going to intentionally crash a heavier part of the rocket into the surface of the moon. But when they did this, the moon sounded like a gong, this time for more than 3 hours and at a depth of more than 32 kilometers. This was not expected at all and still baffles many scientists today. The conclusion is that the moon must be hollow, because it is predominantly made on the surface of a rock called basalt. Although it is a very light rock, it also absorbs impact very well. So if the entire moon were made of that type of rock, you wouldn't expect a reverberation when a large impact occurred. The reason this news is downplayed is because the idea that the moon is hollow simply contradicts everything we know about physics. In his 1966 book, Intelligent Life in the Universe, renowned scientist and astronomer Carl Sagan defined modern scholarship regarding the composition of celestial bodies throughout the cosmos. Carl Sagan suggested that a natural satellite cannot be a hollow object, and this is very strange because the moon would be vibrating unless it was a hollow object. That would suggest that the moon is artificial and that perhaps significant parts of the moon may have been hollowed out. If that is the case, it most likely was not achieved naturally, it would have to have been achieved artificially. This raises the important question of who or what would have had the capacity, skills and technology to do this. Certainly, we couldn't. That would just have to be the work of aliens and no one else. In a turn of events, NASA has recently revealed previously classified evidence suggesting that the Soviets managed to land on Mars. This finding raises intriguing questions. Why did the Soviet Union choose to initially conceal these missions? How many attempts did the Soviets make to reach Mars? The Cold War, defined by intense ideological and political rivalry between the United States and the Soviet Union, generated technological progress that propelled humanity toward the stars. The space race, a vital component of this era, exhibited geopolitical competition and led to a remarkable era of scientific and technological advances. After facing problems and difficult times, the Soviet Union seemed to be winning in the space race, while the United States had disappointments, such as the launch of Sputnik and the flight of Yuri Gagarin. The path to the moon was not only one of successes, as there were also challenges, such as the fire on Apollo 1. Despite this, the United States Apollo 11 was successful in reaching the moon, with an exciting live broadcast that captivated millions. Meanwhile, Soviet scientists were secretly working on an important project, even bigger than reaching the moon. They wanted to send a human to Mars, a goal that, if achieved, would have been a major milestone in space exploration, long before the current plans of people like Elon Musk. What were the beginnings of these plans and why did they take decades to become known? In short, no one wants to admit mistakes, especially a superpower in the middle of the Cold War. The fierce competition between the United States and the Soviet Union spanned many areas, not just conflicts like in Korea or Vietnam. This led to the Soviet Union hiding problems and failures. In 1960, 9 years before Apollo 11, Soviet scientists already had Mars in mind as an exploration target, beyond the moon. They launched missions in the 1960s to explore Mars, marking a milestone and paving the way for future expeditions. Mars is unique in the solar system, with a rotation of 24 hours and 37 minutes, and an orbital inclination similar to Earth. It has seasonal changes and evidence of a past with water and vegetation, which makes it even more intriguing. The Soviets had a program called Mars to explore Mars with unmanned missions. The first mission, Mars 1, took off in 1962 from the Baikonur Cosmodrome in Kazakhstan. It used the Molniya 8K-78 rocket, an upgrade of the R-7 Semyorka missile. Mars 1 was an automatic interplanetary station that sought to fly over Mars, being the first to do so. He wanted to obtain data about the space between Earth and Mars, explore Martian magnetic fields and take images. The ship had a cylindrical shape with solar panels and antennas for communication. A major problem occurred on March 21, 1963 during their trip to Mars. Communication was cut off due to faulty sensors that consumed power. Mars 2 and Mars 3 were also lost at launch. In 1971, the USSR moved forward with the M4 program, which included Mars 2 and Mars 3. The United States launched Mariner 9. The Mars 2 and 3 missions wanted to soft land on Mars. They used identical ships with orbital and landing modules, plus a rover. The landers would take images and data from the surface. Mars 2 was launched in May 1971 and arrived at Mars in November of that year. About 4.5 hours after reaching Mars, the spacecraft released the descent module. But a problem occurred. The module entered the Martian atmosphere at an incorrect angle and speed, impacting before activating the parachute. It crashed in a specific location. The orbiter adjusted its orbit and activated its instruments near Mars. Mars 3, part of the USSR's Mars program in the 1970s, had an orbiter and a lander. The module landed in December 1971 and transmitted images to Earth, but lost contact. It was suggested that a dust storm caused signal loss, similar to war situations. Mars 3 provided data about Mars, such as low pressure and cold temperature. The Mars 3 orbiter had fuel problems and had a different orbit. It also carried a small rover called Prop-M, which explored Mars on skis to avoid trouble. Despite being simple, the rover test was successful. Upon landing, Mars 3 successfully released the rover and continued on its intended path. After an hour of nervous waiting, they finally received a signal, but had to adjust its intensity. The data showed a gray image with no clear details, and the signal disappeared within 14.5 seconds, baffling the team. After discussions with scientists and engineers, Permanov examined the image again, concluding that a dust storm had disrupted communication with Earth. This ended the Mars 3 mission, considering it successful. On February 10, 1974, the Mars 4 orbiter was launched and arrived at Mars. However, a failure in a transistor affected its performance, and the braking rockets did not work, causing it to pass close to Mars. Despite that, he captured images and radio data, revealing details about Mars' nighttime ionosphere. It then continued transmitting data from an orbit around the Sun, attempting to approach Mars again on February 12, 1974. Mars 5, launched in August 1973, managed to reach Mars and enter an elliptical orbit with an inclination of 35.3 degrees. Their cameras could take 12 photos on each approach. It collected data in 22 orbits before losing pressurization in its transmitter. Mars 6, launched in August 1973, reached Mars in March 1974, but lost contact during descent. It landed on Margherita Fratera, transmitting atmospheric data, although much was unreadable due to component failure. Mars 7, launched in August 1973, arrived at Mars in March 1974, but had problems with its systems and passed close to the planet earlier than planned. How did the Soviets handle this situation? Although they hid the launches as state secrets, more space missions were known. To hide failed missions, they called them Cosmos or Sputnik, and sometimes disguised them as Earth satellites. The Mars 2 and 3 missions generated mystery in 1971, only revealing the successes of the orbiters. The truth was not known until the 1990s. The Soviet Mars program had little success, with only one probe having relative success. The others faced problems. In 2007, an image of Mars revived interest in searching for debris from Mars 3. In 2011, debris from the parachute was claimed to be seen, but the fate of the rover remained unclear. Although limited, the Mars 3 mission provided valuable lessons for future exploration, improving our understanding of the challenges in studying Mars. Mars has been a major focus for NASA for decades, attracting scientists for its geological history and the possibility of extraterrestrial life. Upcoming missions to Mars, such as the Sample Return mission, mark a milestone in planetary exploration. This collaboration with ESA plans to bring samples from Mars to Earth for detailed analysis. The Mars 2020 Perseverance rover paved the way, collecting samples for return. One lander will carry an ESA rover to collect the samples, launched by a small Martian rocket. Finally, an orbiter will bring the samples back in a complex but exciting process. Once on Earth, the samples will be available to scientists around the world in advanced laboratories. The analyses will go beyond what rovers and instruments on Mars can achieve. The resulting data will provide valuable insights into the history, geology, and possibility of past life on Mars. The Mars Sample Return mission is a transformative step in our quest to understand this neighboring planet. Despite notable failures in the Soviet Mars program, their efforts laid a solid foundation for future exploration. The lessons learned drove technological advances and a deeper understanding of interplanetary travel, strengthening our spacecraft and increasing confidence in Mars exploration.